Hello everybody, we're getting ready to do section 15 for SAT Math Level 2 preparation. The classwork sheet for this, which is 12 points on your notebook guide. For section 15, three-dimensional geometry, and then you got 12 points on your classwork sheet. Students in my classroom, name, date, period, due date for my onliners and homeschoolers. And page 1, a notebook entry here. The level 2 mathematics subject test may have problems that involve 5 types of solids: prisms, pyramids, cylinders, cones, and spheres. Rectangular solids and cubes are special types of prisms. In a rectangular solid, the bases are rectangles, so any part of opposite sides can be bases. In a cube, the bases are squares and the altitude is equal in length to the sides of the base. On the level 2 mathematics subject test, all figures are assumed to be right solids. Formulas for the volumes of regular pyramids, circular cones, and spheres, and the formula for the surface area of a sphere are given in the test book. For convenience, formulas for the volumes and lateral areas of all these figures are summarized. So here they are. This goes into your notebook. This should be on your notebook guide too, students. So we have a prism here. Your volume is V equals BH. Surface area is PH plus 2B. And then we have rectangular solid here. There's your volume formula, then here's your surface area formula here. And a cube, same thing here, volume, surface area. And then a pyramid, volume, surface area. And cylinder, volume, surface area. And then a cone, volume, and surface area. And a sphere, volume and surface area. The variables in these formulas are defined as follows. So V equals volume, SA is surface area, B is base area, and then P is your base perimeter, then L would be your slant height, H altitude, L length, W width, R radius, and S would be side length. And using the notation above, the formula for the length of a diagonal of a rectangular solid is D equals, and then we have square root of T squared plus W squared plus H squared, which is derived from 2 applications of the Pythagorean theorem. One type of problem that might be found on the level 2 mathematics subject test is to find the volume of the space between 2 solids, one inscribed in the other. This is solved by finding the difference of volumes. In this type of problem, you are given only some of the necessary dimensions. You must use these dimensions to find the others. You might be asked to find a dimension of a figure if its volume and surface area are equal. The third type of problem involves percent changes in the dimensions of a figure. So let's get into an example here. A, the length, width, and height of a right prism are 9, 4, and 2 respectively. What is the length of the longest segment whose endpoints are vertices of the prism? So how do we go about solving that? The longest such segment is a diagonal of the prism, so it would be a diagonal of the prism, something like that, and then be a diagonal. The length of this diagonal is, here we go, and then we have a kind of like a formula here to find the length of a segment. 9 squared plus 4 squared plus 2 squared, and then we take the square root of that, and we get square root of 101, so it'll be a little bit over 10, right? B, a sphere of a diameter of 10 meters is inscribed in the cube. What is the volume of the space between the sphere and the cube. So what is the volume of the space between the sphere and the cube? So you need to subtract the volume of the sphere from the volume of the cube. The radius of the sphere is 5 and the volume is 4/3 pi, 5 cubed, which equals this number here, 523.6 cubic meters. Since the sphere is inscribed in the cube, the side length of the cube is 10 meters and its volume is 1,000 cubic meters. The volume of the space between them would be 476.4 cubic meters. Okay, so example C, a cylinder has a volume of 500 cubic inches. What is the radius of the cylinder if its altitude equals the diameter of its base? So with this kind of question here, the formula for the volume of a cylinder is volume is pi r squared h. If h equals 2r, this formula becomes volume equals 2 pi r cubed. Substitute 500 for v and solve for r to get r equals 4.3 inches. So that'd be a fast way there of plugging in a value that you already know into the established formula there. And then for example D, if the volume of a right circular cone is reduced by 15% by reducing its height by 5%, by what percent must the radius of the base be reduced? So again, we use our formula up here. If the volume of the cone is reduced by 15%, then 85% of its original volume remains. If its height is reduced by 5%, 95% of its original height remains. Use the formula for the volume of a cone. Now let P be the proportion of the radius that remains. So we got 0.85 times 1/3 pi r squared h, which would equal 1/3 pi times pr squared multiplied by 0.95 h. This equation simplifies to 0.85 equals 0.95 p squared, so p equals 0.946. Therefore, the radius must be reduced by 5.4%. So that's a pretty cool way of finding that one out. Okay, the coordinate plane can be extended by adding a third axis, the z-axis, which is perpendicular to the other two. Picture the corner of a room. The corner itself is the origin. The edges between, and down here would be like the corner here. Here's your corner. The edges between the walls and the floor are the x and y axes. Here's your x-axis. Here's your y-axis. The edge between the two walls would be the z-axis right here. The first octant of this three-dimensional coordinate system and the point 1, 2, 3 are illustrated below. Here we go right here. So this would be in what they call the first octant, which would be out here. And then here's point 1, 2, and 3 right here. X would be 1, Y would be 2, and then Z would be our 3 right there. A point that has 0 as any coordinate must lie on the plane formed by the other two axes. If two coordinates of a point are 0, then the point lies on the non-zero axis. The three-dimensional Pythagorean theorem yields a formula for the distance between 2 points x1, y1, z1, and x2, y2, z2 in space. So here it is here. Here is your three-dimensional Pythagorean. And we get a distance formula here, x2 minus x1, y2 minus y1, z2 minus z1. And then we take the square root of that sum. A three-dimensional coordinate system can be used to graph the variable z as a function of the two variables x and y, but such graphs are beyond the scope of the level 2 mathematics subject test. So just a little note there. A sphere is a set of points in space that are equidistant from a given point. If the given point is ABC and the given distance is r, an equation of the sphere is x minus a quantity squared plus y minus b quantity squared plus z minus c quantity squared equals r squared. If only two of the variables appear in an equation, the equation describes a planar figure. The third variable spans the entire number line. The resulting three-dimensional figure is a solid that extends indefinitely in both directions, parallel to the axes of the variable that is not in the equation, with cross-sections congruent to the planar figure. Okay, there's a lot of words there. So we definitely would need a visual of that. Example G, describe the graph of the set of points x, y, and z where x squared plus z squared equals 1. So in this case, since y is not in the equation, it can take any value. When restricted to the xz plane, the equation is that of a circle with radius 1 in the center at the origin. Therefore, in xyz space, the equation represents a cylindrical shape centered at the origin that extends indefinitely in both directions along the y-axis. That would be how you would explain that. H. If the segment of the line y equals negative 2x plus 2 that lies in quadrant 1 is rotated about the y-axis, a cone is formed. What is the volume of the cone? So we have our situation here. What is the volume of that cone? So as shown in the figure here, here is our line here. As shown in the figure, the part of the segment that lies in the first quadrant. So here would be our first quadrant part of this line. If the segment of line negative 2x plus 2, here's our y-intercept, here's our negative 2x, that lies in quadrant 1 rotated about the y-axis, so it should go something like that, right? Should circle around. So here's our original. And the axes form a triangle with vertices 0, 0, 1, 0, and 0, 2. Rotating this triangle about the y-axis generates a cone shown here. So the thing, like, it circles around like this on the base, and that would be your cone right there. The radius of the base will be 1, so we got a radius here of 1. And the height would be 2. Therefore, the volume is, volume equals 1/3 pi r squared times the height, which is 2, which will become 2/3 pi for the volume of this cone. And that is lesson 15 of SAT Math Level 2 Prep. Animated PowerPoint math video at AOL.com. For questions or course materials, thank you very much.